Welcome to the Explainer. Okay, if you're stressing out right now about cramming for your grade 12 IT practical and theory exams, just take a deep breath. You are literally in the perfect place. I know exactly how overwhelming it can be trying to memorize every single definition, concept, and line of code right before you walk into that exam room. So today, we're doing a high-octane, perfectly structured crash course. We're going to cover everything you need to know from chapters 1 through 7. No fluff, just the exact facts, definitions, and practical steps you need to absolutely ace this thing. Let's get into it. Here's our cheat sheet for today. 1. Demystifying data and databases. 2. Mastering database keys. 3. Data quality and normalization. 4. Maximizing CPU performance. And 5. Connecting Delphi to databases. All right, let's dive right into Section 1, Demystifying Data and Databases. Okay, here's a rapid-fire way to lock these fundamental definitions right into your brain. First, we have data. This is just your raw, totally unprocessed numbers and facts. Second, a database is the organized collection of that data. You can think of data as your raw ingredients, and the database, well, that's your perfectly organized kitchen pantry. Finally, the DBMS, or Database Management Software, is the chef managing the whole operation. The DBMS is the actual software, like Microsoft SQL Server, Access, or MySQL, that creates the database, manages the tables, and handles all the security. Now watch out for this one, because it's a classic exam trap. Examiners absolutely love asking for the difference between a standard database and data warehousing. A standard database stores current, day-to-day transactions. It's what's happening right now in the business. Data warehousing, on the other hand, is a technique for storing massive quantities of historical data gathered from various databases. You wouldn't use a data warehouse to ring up a single sale today. You'd use it to analyze overall sales trends over the last 10 years. So you might be wondering, how does all this data actually get into our databases in the first place? And what do we do with it? First, consider RFID, which stands for Radio Frequency Identification. These are tiny little chips that store a few kilobytes of information and transmit it via radio frequencies straight to a reader. It's exactly how products in a massive warehouse or those toll gate tags on your car automatically record data without anyone manually typing a thing. And once we actually have all that data, we use data mining. Data mining is the process of analyzing these massive datasets to identify trends or patterns. Ultimately, this is used to drastically improve decision-making, like predicting future market trends. Moving right along to Section 2, Mastering Database Keys. You're going to want to take a mental screenshot of this right now. If you get a question on database structure, you absolutely must know these definitions. A primary key is a compulsory field that holds a totally unique identifier for each specific record. An alternative key is another field with unique values, but, well, it just wasn't chosen as the primary one. Now, the foreign key is crucial. This is a field with values that exactly match another table's primary key, and its whole job is to link those tables together. Finally, a composite key is a combination of two or more fields that, when put together, uniquely identify a record. All right, let's hit Section 3, Data Quality and Normalization. Okay, quick question. What is the exact difference between data validation and data verification? I guarantee you will see this heavily weighted on your paper, and honestly, it is the #1 thing students mix up. Let's clear it up once and for all. So here is the crucial distinction. Validation is the computer doing the heavy lifting. It's the process of checking if the data is in the correct format or type before adding it. For example, making sure an age field actually contains numbers and not letters. It also helps prevent nasty malicious attacks like SQL injection. Verification, conversely, is a manual technique used to make sure the data is actually truthful and accurate. It requires a real human. Remember it like this: validation checks the format, verification checks the truth. If you get one of those long-form questions asking how to determine if data is valuable, just list these 5 specific qualities. Valuable data absolutely must be accurate, meaning correct and precise; consistent, which means you don't have conflicting duplications across the database; current, meaning it's up to date; complete, meaning there are no frustrating gaps in the information; and relevant, meaning it's actually useful to the people using it. Memorize those 5 words for sure: accurate, consistent, current, complete, relevant. To actually maintain those 5 qualities, we use normalization. Normalization is your ultimate database cleanup solution. It's a systematic, multi-step approach of decomposing tables to completely eliminate data redundancy. And data redundancy just means having the same exact piece of repeating data held in two different places. That wastes space and causes major errors. Normalization fixes this. It removes all those nasty insertion, modification, or deletion anomalies and makes the relationships between your tables highly efficient. Time to switch gears to hardware in Section 4, Maximizing CPU Performance. There are two major concepts you need to grasp here. First up, CPU speed. This is a direct measurement of how many instructions the CPU can complete per second, and it's closely linked to its clock speed, which we measure in megahertz or gigahertz. Basically, the faster the clock, the faster your apps run. Second is virtualization. Because modern CPUs are so ridiculously powerful now, we can use virtualization to break a single physical computer into many virtual machines. Each virtual machine gets its own allocated CPU, RAM, and storage, running its own operating system entirely separated from all the others. It's like having 5 computers stuffed inside one. Okay, here's another massive terminology trap. Do you know the exact difference between multitasking, multithreading, and multiprocessing? I mean, they sound completely identical, right? But they function very differently under the hood. Let's break this comparison down clearly so you don't lose marks here. Multitasking is when a single processor splits its time between different, entirely separate processes. Multithreading, on the other hand, is when the processor completes multiple different tasks, which we call threads, inside the exact same program by rapidly switching between them. And multiprocessing, well, that is simply using many different physical processors to complete tasks simultaneously. Keep those 3 definitions distinct in your mind. Finally, let's bring it all together in Section 5, Connecting Delphi to Databases. If you're taking the practical exam tomorrow, consider this your ultimate survival checklist. When you need to set up a database connection in Delphi, you follow these exact steps. Step 1, drop an ADO table component right from the palette. Step 2, in the Object Inspector, click the little ellipse to build the connection string, and make sure to choose the Microsoft Jet 4.0 OLDB provider. Step 3, select your specific MDB database file. Step 4, and whatever you do not forget this. Erase the username admin and make absolutely sure blank password is selected before you click OK. When you start building out those interfaces that actually pull from your data using object-oriented programming, or OOP, remember your structure is everything. You must type in the word interface to begin, and you must add a uses statement. To be safe, always include uses, sysutils, dialogues, math, so your self-contained modules have the exact libraries they need to process information correctly. Don't skip that step. And there you have it. We have successfully powered through the database fundamentals, all the essential keys, normalization, CPU performance, and the exact steps to connect Delphi. Remember, mastering these terms isn't just about surviving a practical exam. You now literally hold the building blocks of the software that runs our entire modern society. So as you sit down at that desk to write your code and link your tables, ask yourself, how will the systems you build today shape the automated world of tomorrow? You've got this. Good luck.